Okay, so number one, let me go ahead and what University of Central Florida. Actually, your team's good. My team's bad right now, but whatever. But it's cold in my room as always. But we need to be able to translate back and forth between pH and H plus concentration, right? Concentration, remember, is molarity. That's a capital M, which is moles per liter. So you take the number of moles of acid divided by the number of liters of solution, kind of water, right? And that'll give you your molarity. The higher that number is, the more concentrated it is. So a big number here, which that's a pretty small number, right? Big numbers there mean they're very concentrated. So they'd be more dangerous, like drain cleaner, right? That's going to be more than 1 molar, right? That's, I think, around 10 molar or something, if I remember right. So the higher this number is, the more concentrated it is. Since these are both acidic things, we know they're both going to have low pHs, but those things would also have OH minus stuff in them. But we're just going to kind of focus on how to do the calculation. To go from H plus to pH, and again, good idea to pause this and work ahead of me on those as you can. But to go from H plus to pH, I do the negative log of the H plus concentration. So that's going to be negative log of 0.00301 molar. So I can do that on a couple of different calculators. If you've got a Texas Instruments style calculator, and it doesn't have to be a graphing calculator, but a Texas Instruments style, your log button is right here usually, right around the 7. With this style, this is also a Texas Instruments, but this is the ones we have at school. That log button, whoops, I don't know my left and my right when I'm looking on the screen there. The log button is right here. All right, so either way, I type it in the same, negative log of 0.00301, and then that's going to give me 2.52. Right, so 2.52 would be my pH. There's no units. When you do a log, that kind of blows up any units that'd be there. The units here are molar, but because there's an exponential thing there, it's just a unitless number kind of thing, right? I can do the reverse, right? Here I have the pH and I want the H plus. We can look and see Coke is more acidic than Diet Coke. So my concentration in Diet Coke should be less than that in Coke, right? So if I do the reverse of this reaction, that's going to, not the reverse of the reaction, the reverse of the math, that's going to be 10 raised to the negative of the pH. This is going to be anti-log, is how you get that. Anti-log of negative 3.2. So I'll use the other calculator this time. So again, the log is right here on the side. And I'm going to have to hit second to get that anti-log, right? So I'll do second log, which is the anti-log, negative 3.2. Don't use minus 3.2. The calculator uses that minus, right? This is minus, this is negative for that. And that's going to give me 6.3 times 10 to the negative fourth. Or if you don't want that in scientific notation, right? Can you still see me okay here? Yeah. That's going to move my decimal point 4 places. So 0.00063. So if we look, Coke is more acidic than Diet Coke, right? It's got more, a higher concentration of H plus than Diet Coke does, right? They are different, a little bit different chemically because of the amount of sugar and all that kind of stuff.